Imagine Antarctica, a frozen alien world at the bottom of our planet. Beneath its endless ice, scientists have detected mysterious signals, strange whispers that defy explanation. These signals, discovered in 2025, are unlike anything we've seen, challenging our understanding of the universe. They're radio waves, but not the kind that should exist here, behaving in ways that break the rules of physics. It's as if something unknown is knocking from deep within the ice. This puzzle has electrified scientists, sparking debates and wild theories. Could it be a new particle, a clue to dark matter, or something even stranger? The quest to solve this Antarctic mystery is just beginning. It's a story of curiosity, brilliant minds, and the thrill of the unknown. The universe still holds secrets, sometimes hidden right beneath our feet. Meet ANITA, the Antarctic Impulsive Transient Antenna, our cosmic detective. Suspended high above the frozen expanse, ANITA is not your average scientific instrument. It's a marvel of engineering, designed to float at the edge of space and listen for the faintest signals from the universe. Suspended from a balloon as tall as a skyscraper, ANITA soars 24 miles above Antarctica, scanning a continent-sized sheet of ice. From this incredible vantage point, it can observe an area larger than some countries, making it the perfect cosmic lookout. Its mission? To catch high-energy neutrinos, ghostly particles that zip through space, born in the heart of exploding stars and distant galaxies. These elusive messengers carry secrets about the most violent events in the cosmos, and ANITA is one of the few instruments on Earth capable of detecting them. When a neutrino hits the ice, it creates a faint radio flash, lasting just a fraction of a second. ANITA's sensitive antennas are tuned to catch these whispers, filtering out the noise to find the rarest signals. Antarctica is the perfect lab. Pure, ancient ice, almost no radio interference, and an endless sky. The isolation and clarity of this environment make it possible to detect signals that would be lost anywhere else on Earth. From 2006 to 2016, ANITA drifted on polar winds, circling the continent and gathering mountains of data. For weeks at a time, it watched for cosmic messengers, patiently waiting for the universe to reveal its secrets. But then, something strange happened. ANITA detected signals that didn't come from the sky, but instead seemed to rise up from the Earth itself, an unexpected twist that left scientists puzzled. These upward signals didn't fit any known pattern. They defied explanation, challenging everything researchers thought they knew about cosmic rays and neutrinos. The team, a global group of scientists from many countries, realized they'd stumbled onto a new mystery. What could cause such bizarre signals? Was it a new kind of particle or something even stranger? ANITA's mission had changed. Now it was chasing a puzzle no one saw coming. The search for answers would push the boundaries of science and imagination. The hunt for answers had begun. Scientists worked late into the polar night, determined to unlock the secrets hidden beneath the ice. Antarctica was hiding more than anyone imagined. In this frozen wilderness, the universe had whispered a new riddle, and ANITA was listening. Neutrinos, often called ghost particles, are among the universe's strangest and most elusive creations. They are so mysterious that for decades, scientists weren't even sure they existed. These tiny particles are nearly massless, have no electric charge, and pass through everything, even you, by the billions every single second, completely unnoticed. Right now, as you watch this, trillions of neutrinos are streaming through your body, through the Earth and out the other side, as if nothing were there at all. Neutrinos are born in the hearts of stars, in the fiery explosions of supernovae, and in the most violent cosmic events imaginable. They travel across the universe at nearly the speed of light, carrying with them secrets from the most extreme and energetic places in existence. Unlike light, which can be blocked, scattered, or bent by matter, neutrinos travel in straight lines, almost never interacting with anything. They deliver pure, unfiltered information from their origins, making them cosmic messengers from places we could never otherwise see. But catching a neutrino is nearly impossible. They are so shy, so reluctant to interact, that most pass through the entire Earth without leaving a trace. Detecting even a single one requires extraordinary effort and ingenuity. That's why scientists have turned to Antarctica, using its vast clear ice as a giant natural detector. The ice is so pure and so massive that it gives us a rare chance to spot these ghostly visitors. When a high-energy neutrino finally collides with an atom in the ice, it creates a spectacular shower of particles and a brief, faint flash of radio waves, an almost invisible signature of its passing. ANITA, a scientific balloon flying high above the Antarctic ice, listens for these rare and fleeting flashes, scanning the frozen continent for signs of cosmic neutrinos. By studying these elusive signals, scientists can map the high-energy universe, trace the origins of cosmic rays, and unlock some of the deepest mysteries of the cosmos. It's a clever and creative way to see the invisible, to peer into realms that would otherwise remain forever hidden. But sometimes, the universe surprises us, sending a signal so unexpected that it challenges everything we thought we knew. ANITA's data was supposed to reveal neutrinos from space. Instead, it detected powerful radio pulses that didn't fit the script. The first odd signal in 2006 was upside down. Its polarization was the reverse of what neutrinos should produce. The team checked for errors, reflections, anything, but the anomaly persisted. It looked like a particle had shot up from the ice, not down from space. This was impossible. According to physics, nothing should do that. Then, in 2014, it happened again. Another upward, powerful signal. Two bizarre events, both breaking the rules. Dr. Stephanie Wissel and her team were baffled. These weren't neutrinos, but what were they? The signals were real, but their origin was a mystery. The Antarctic ice had become a stage for something unknown. The scientific world was hooked. The search for answers intensified. The puzzle was only getting deeper. The real shock? These signals didn't just come from the sky or the horizon. They came from deep within the Earth itself, shooting up at steep, impossible angles. Imagine a burst of energy, not falling down from space, but rising up from the frozen heart of Antarctica, as if the planet itself was sending a message. For a particle to do that, it would have to travel through thousands of miles of dense rock and ancient ice, an impossible journey for any known particle. The path would take it straight through the planet's core, mantle, and crust, a route that should stop even the most elusive cosmic travelers in their tracks. Even high-energy neutrinos, those ghostly particles famous for passing through matter as if it weren't there, can't make it through the entire planet at these extreme energies. At such high energies, the Earth should act like a solid wall, blocking their passage completely. The Earth, in effect, should be completely opaque to them. No known particle should be able to emerge from the other side, let alone at such a steep angle. ANITA's team double-checked their findings and reached out to other detectors. IceCube in Antarctica, the Pierre Auger Observatory in Argentina, hoping for a clue, a matching signal, or even a hint of an explanation. But no other observatory, anywhere in the world, saw anything similar. The signals were unique, isolated to ANITA and to Antarctica. The signals were real, confirmed by careful analysis and repeated checks, yet their source defied every explanation the scientists could imagine. It was as if a baseball had passed through a steel wall without a scratch, something that simply shouldn't be possible according to everything we know about physics. The evidence was solid, the data clear, but the laws of physics offered no answers. The world's best minds were left scratching their heads, staring at equations that no longer seemed to add up. Something new, something utterly unexpected was happening beneath the Antarctic ice. It was as if the universe had decided to reveal a secret, right at the bottom of the world. The scientific community was left with a tantalizing question. What kind of particle, or what new force of nature, could possibly do this? Was this a hint of new physics, or a sign that our understanding of the universe was incomplete? The search for answers began in earnest. Teams around the world started looking for a new kind of particle, or perhaps even a new law of nature. The mystery had ignited a wave of curiosity and excitement in the scientific world. The story quickly spread beyond the labs and observatories. News outlets around the globe picked up the mystery, and Antarctica became the focus of a worldwide scientific obsession. Antarctica was now the center of a cosmic riddle. The world was watching, waiting for the next clue to emerge from the ice. The ANITA signals challenged the standard model, the rulebook of particle physics. This model has explained the universe's building blocks for decades, passing every test, until now. According to the rules, nothing should travel through the Earth and emerge with such energy. Either our understanding of neutrinos is wrong, or ANITA saw something entirely new. For scientists, this is thrilling. A crack in the theory means a chance for discovery. Every breakthrough starts with an unexplained result. The ANITA events are a flashing sign. There's more to the universe than we know. It's time to look beyond the standard model. The hunt for new physics is on. With no known explanation, scientists are dreaming big. One idea, a new particle called the sterile neutrino, so ghostly it could slip through the Earth where others can't. Another, the signals might be linked to dark matter, the invisible substance making up most of the universe. Or maybe, just maybe, there's something strange about the Antarctic ice itself. So far, no ice effect explains the steep, powerful signals. These are just hypotheses. Each needs testing. More data is crucial. More events must be found. The scientific process is in full swing. Propose, test, discover. The world's best minds are on the case. The answer could change everything. To solve the mystery, scientists are building a new experiment. Pueo. Named after a Hawaiian owl, Pueo will soar above Antarctica, sharper and more sensitive than ANITA. With more antennas and advanced tech, it will catch even fainter signals and distinguish real events from reflections. The goal: find more upward-traveling signals and map their origins. With a bigger dataset, scientists can finally test their wildest theories. Dr. Wissel and her team are leading the charge, backed by major research organizations. Pueo could unlock a new chapter in physics. The world is waiting for its first flight. The next great discovery may be just above the ice. The adventure continues. Antarctica's mysterious signals are more than a puzzle. They're a celebration of curiosity. Science thrives on surprises, and sometimes the biggest discoveries come when we least expect them. This global quest unites scientists, inspires wonder, and reminds us how much we have yet to learn. The search for answers is a journey, not a straight line. Every new signal brings us closer to rewriting what we know about the universe. So, when you hear about strange discoveries, get excited. It means we're on the edge of something new. Stay curious, ask questions, and follow the adventure. The universe is vast, mysterious, and full of secrets. The whispers from Antarctica invite us to listen and to keep exploring.